For millennia, humanity has looked up at the night sky. We've gazed at the twinkling stars, the wandering planets, and the mysterious moon. Ancient civilizations like the Babylonians meticulously charted these celestial movements. They saw patterns, they told stories. They built calendars around these cosmic rhythms. The Greeks pondered the nature of the universe, proposing models that, while not always correct, sparked critical thought. Chinese astronomers, too, kept detailed records of comets, eclipses, and guest stars' supernovae events that reminded us of the dynamic, ever-changing cosmos. This ancient curiosity, this innate desire to understand our place in the vastness, was the very first step on our journey to the stars. It was the seed of exploration planted deep within the human spirit. Then came the dreamers who thought beyond mere observation. They imagined actually there. One such visionary was Konstantin Tsiolkovsky, a brilliant Russian schoolteacher who, in the late 19th and early 20th centuries, laid down the theoretical foundations for spaceflight. He wasn't just looking, he was calculating. Tsiolkovsky developed the famous rocket equation, a fundamental principle that describes how rockets work. It explains the relationship between a rocket's speed, its mass, and the velocity of its exhaust. He envisioned liquid-fueled rockets, multi-stage designs, and even space stations. He understood, long before it was practical, that escaping Earth's gravity required serious thrust and clever engineering. His ideas were a blueprint for future explorers. The path from theory to reality, however, often takes unexpected turns. World War II, a period of immense global conflict, paradoxically accelerated rocket technology. The German V2 rocket, designed by Wernher von Braun and his team, was a weapon of war, yes, but it was also the most advanced rocket built to that date. It could reach the very edge of space. After the war, both the United States and the Soviet Union recognized the strategic importance of this technology and the expertise behind it. This wartime innovation, born from destructive intent, inadvertently provided the hardware and the know-how that would soon launch humanity into orbit. It's a complex legacy, but an undeniable part of the story. So the stage was set. We had ancient wonder fueling our curiosity. We had the mathematical principles from pioneers like Tsiolkovsky, and we had the technological leap, albeit one born from conflict, provided by early rocketry. The universe was beckoning, and humanity, armed with new knowledge and powerful engines, was finally getting ready to answer that call. The dream of reaching for the stars was slowly, painstakingly, transforming into a tangible possibility. The cosmos was vast, but our ambition was growing even faster. The age of looking up was about to become the age of going up. The mid-20th century brought the Cold War, a period of intense geopolitical rivalry between the United States and the Soviet Union. This global chess match extended beyond Earth's atmosphere, igniting what we now call the space race. It wasn't just about scientific discovery, it was about demonstrating technological superiority, ideological strength, and national prestige. Every launch, every milestone was scrutinized, celebrated, or lamented, depending on which side you were on. This intense competition, while stressful, dramatically accelerated the pace of space exploration. The desire to be first to plant a flag pushed engineers and scientists to achieve incredible feats in an astonishingly short period. It was a high-stakes game played out on a cosmic scale. On October 4th, 1957, the world changed forever. The Soviet Union launched Sputnik 1. This small, beeping, metallic sphere became the first artificial satellite to orbit the Earth. The beep, beep, beep signal from Sputnik was heard around the globe, a clear announcement that humanity had breached the final frontier. For the Soviets, it was a triumph. For the Americans, it was a wake-up call. The Sputnik shock prompting a massive investment in science, education, and aerospace technology. Suddenly, space wasn't just for astronomers and science fiction writers, it was a real place, accessible and politically charged. Sputnik didn't just orbit the Earth, it orbited our consciousness. The Soviets continued to score early victories. On April 12, 1961, cosmonaut Yuri Gagarin became the first human in space, completing an orbit of the Earth aboard Vostok 1. His famous exclamation, "Poyakhali, let's go," captured the adventurous spirit of this new era. Gagarin became an instant global hero, a symbol of human courage and the potential to transcend terrestrial boundaries. His flight proved that humans could survive and function in the harsh environment of space. It was a profound moment, demonstrating that the dream of human spaceflight was now a stunning reality. The stars were no longer just distant points of light, they were destinations. The United States, spurred by these Soviet successes and President John F. Kennedy's bold challenge, set its sights on an even more audacious goal: landing a human on the moon and returning them safely to Earth before the end of the 1960s. This led to the Apollo program, a monumental undertaking involving hundreds of thousands of people and unprecedented technological innovation. And on July 20th, 1969, the world watched, breathless, as Neil Armstrong and Buzz Aldrin of Apollo 11 took those first historic steps on the lunar surface. That's one small step for a man, one giant leap for mankind. It was more than a landing. It was a testament to human ingenuity, determination, and our unyielding drive to explore the unknown. After the frenzy of the moon race, the focus of space exploration began to shift. It wasn't just about getting there anymore. It was about learning to live and work in space for extended periods. This led to the development of the first space stations. The Soviet Union launched Salyut-1 in 1971, the world's first crewed space station. The United States followed with Skylab in 1973, a workshop made from a converted Saturn V rocket stage. These early orbital outposts were crucial laboratories, allowing us to study the long-term effects of microgravity on the human body and conduct unique scientific experiments that couldn't be done on Earth. They were our first tentative homes beyond our home planet. The Soviet Union, later Russia, particularly excelled in long-duration spaceflight with its Mir space station. Launched in 1986, Mir, meaning peace or world, was a modular marvel. It was assembled in orbit, piece by piece, over a decade. Cosmonauts and international astronauts lived and worked on Mir for extended missions, some lasting well over a year. Mir taught us invaluable lessons about spacecraft engineering, life support systems, and the psychological challenges of long-term isolation in space. It was a testament to endurance and international cooperation, even during politically tense times on Earth. Mir truly pushed the boundaries of how long humans could reside off-planet. To service these burgeoning orbital platforms and conduct other missions, a new type of spacecraft was needed, something reusable. Enter the Space Shuttle program by NASA. First launching in 1981 with Columbia, the Space Shuttle was a revolutionary concept. A winged vehicle that could launch like a rocket, operate in orbit like a spacecraft, and land on a runway like an airplane. For 3 decades, the shuttle fleet, Columbia, Challenger, Discovery, Atlantis, and Endeavour, deployed satellites, conducted research, repaired the Hubble Space Telescope, and, crucially, helped construct the largest structure ever built in space, the International Space Station. It was the workhorse of a generation. The International Space Station, or ISS, is perhaps the grandest example of peaceful global collaboration in science and engineering. Construction began in 1998, with modules and components contributed by the United States, Russia, Europe, Japan, and Canada. Continuously inhabited since November 2000, the ISS is a football field-sized laboratory orbiting Earth every 90 minutes. It's a place where astronauts from diverse backgrounds work together, conducting thousands of experiments in biology, physics, astronomy, and materials science. The ISS isn't just a station. It's a symbol of what humanity can achieve when we work together, a stepping stone for future voyages deeper into the cosmos. As we moved into the 21st century, the landscape of space exploration began to transform once again. For decades, it had been the domain of national governments and their space agencies, but a new era was dawning, the rise of commercial spaceflight. Companies like SpaceX, founded by Elon Musk, and Blue Origin, founded by Jeff Bezos, started to challenge the old paradigms. They brought innovation, competition, and a relentless drive to reduce the cost of access to space. SpaceX, with its reusable Falcon rockets and Dragon capsules, began launching cargo and then astronauts to the International Space Station, marking a significant shift towards public-private partnerships. This commercial revolution is democratizing space. The allure of Mars, the red planet, has captivated us for centuries, and now it's a primary focus of robotic and eventually human exploration. NASA has sent a fleet of orbiters, landers, and rovers like Spirit, Opportunity, Curiosity, and Perseverance to scrutinize Mars. These robotic emissaries have revealed a world that was once warmer and wetter, potentially capable of harboring life. They search for signs of past microbial life, have studied the Martian climate and geology, and test technologies that could support future human missions. Each image, each data point brings us closer to understanding our planetary neighbor and the prospect of one day setting foot on its rusty surface. Looking ahead, humanity is poised to return to the moon, this time to stay. NASA's Artemis program aims to land the first woman and the next man on the lunar surface, establishing a sustainable human presence there. This involves building a lunar gateway, an outpost orbiting the moon, and developing lunar landers and habitats. The moon is seen not just as a destination in itself, but as a proving ground, a place to test technologies and gain experience for the even more ambitious goal of sending humans to Mars. It's about building a permanent foothold beyond Earth and learning to live off-world. The future of space exploration is incredibly exciting. We're talking about lunar bases, Mars colonization, and perhaps even ventures to the outer solar system and beyond. The combination of government initiatives and burgeoning commercial capabilities promises an accelerated pace of discovery and development. Challenges remain, of course: technological hurdles, the harsh environment of space, the immense costs. But the human drive to explore, to push boundaries, to understand our universe is a powerful force. The journey that began with ancient stargazers continues, reaching for new heights, new worlds, and a deeper understanding of our cosmic destiny. The universe awaits.